Regarding the genealogy of the FH that runs in your family, I have two possible treatments for you to treat the familial hypercholesterolemia that runs in your family. First is something called statins, and another solution is something called lipoprotein apheresis. And I'll go over how they help, and yeah. Okay, so for statins, another way you can say statins, but it's longer, is HMG CoA reductase inhibitors. And I'll show you where this HMG CoA comes from. So recall that in cellular respiration, you excuse me, you make this a molecule called acetyl CoA in the midst of the process of cellular respiration. So I'll show you that. I'll actually show you that real quick. So this 6-carbon glucose breaks apart into 2 3-carbon pyruvate, and this pyruvate actually turns into acetyl CoA, which is important in oh yeah, and by the way, HMG CoA reductase HMG CoA is one of the essential molecules that are in this 30 something step long process of cholesterol synthesis that I'm obviously not going to go over all of. Okay, so about this pyruvate, they convert to acetyl CoA. And to show you that this pyruvate actually has, okay, so it has 3 carbons. It has 3 carbons that look like that, and they have this carbon over here has 3 hydrogens surrounding it. This carbon is double bonded to an oxygen, and this carbon is also double bonded to an oxygen. This carbon is single bonded to another oxygen. Okay, so we have this pyruvate here, and how this actually turns into acetyl CoA is interesting. This carboxyl group over here actually breaks off and as a byproduct, carbon dioxide actually forms, and now we're left with this acetyl group. This is called an acetyl group over here. This is an acetyl group, and it's going to be bonded to a sulfur that's going to be bonded to a coenzyme A, and this whole thing is acetyl CoA. So that's just a basic way of explaining where this acetyl CoA comes from. And so if you have a lot of acetyl CoA, there's actually one of two ways in which it heads to is part of cholesterol synthesis, which happens in your liver. There's two. We learned that there's 2 ways that you can obtain cholesterol into your body. One, you can eat and obtain cholesterol in your food, and second, which I'm going to go over, is excuse me. Second, which I'm going to go over, is that you can actually produce this cholesterol in your liver. So, I'm not going to draw a liver. Okay, so we have this acetyl CoA over here. If I combine this acetyl CoA with another acetyl CoA, there's an enzyme called diolase that combines these 2 acetyl CoAs, and by the way, it also releases a coenzyme A in the process, and so this diolase essentially combines these 2 acetyl CoAs to form acetyl CoA. And another acetyl CoA is combined in this process with another enzyme known as, I'll use a different color, known as HMG CoA synthase. And according to the name, synth means to combine, to combine. And so HMG-CoA is going to be combined. This acetyl-CoA is going to combine with another acetyl-CoA to form HMG-CoA. And these are like steps to build the cholesterol. And this next step is the most important step because this is the most regulated step for the actual cholesterol that's being produced. In other words, this is the rate limiting step. This is the step that takes the longest and will determine how much cholesterol you actually produce. So the enzyme that actually is responsible for this next step is HMG-CoA reductase, which we see directly from this statin name. So if statins are HMG-CoA reductase inhibitors, then it will inhibit this HMG-CoA reductase from further moving into this process of cholesterol synthesis. And so eventually, without these statins, let's say without these statins, this process will continue as normal, and eventually there's like 20 something more steps. Eventually, it will lead to the production of cholesterol, and then you can make a lot of things with cholesterol, like hormones, lipoprotein. There's a lot of cholesterol derivatives, but what we're concerned about is this is the lipoprotein that harms the human body, the people with FH, which is what we're concerned about in your family. So we don't want this LDL. So we don't want this cholesterol. And so by stopping this HMG-CoA reductase, by inhibiting this HMG-CoA reductase from further going into this process of cholesterol synthesis, we're preventing the liver from producing more cholesterol, and thus preventing more cholesterol in the bloodstream, and thus preventing the plaque buildup, or otherwise known as atherosclerotic activity. And too much of this plaque buildup, or otherwise known as atherosclerotic activity, can actually lower your risk of heart attack and stroke. So that's actually what we want, and that's how statins actually work in protecting lowering the risk of heart attack and stroke in individuals like you with like your family with familial hypercholesterolemia. So that's a class of drugs that you can use to deal with the hypercholesterolemia that you have. Another solution that we can offer is lipoprotein apheresis, which is essentially a process where you remove the patient with hypercholesterolemia in the blood. Let me reword this. Lipoprotein apheresis is a process where you remove plasma from a patient with familial hypercholesterolemia, and then with the plasma that you remove the unhealthy cholesterol that's in that plasma, because the cholesterol resides in the plasma part of the blood. So we take away this, we filter out this cholesterol from the blood, and then we put back the cholesterol deprived plasma back into the blood, so that we have less of this bad cholesterol in the blood. So I'll draw a little like arm here, and then we can insert this device in your vein, and then there's this LDL filtration device where we fill up this plasma, and I'll use orange to represent the LDL. And so with this device, it's really smart, by the way. So it removes the it specifically removes the bad cholesterol from the blood. And so I said the orange represents the LDL. So it will actually take away this LDL from this plasma, and so we don't have this LDL anymore. And then once we don't have this LDL anymore, no LDL, we put it back into the blood. where we put it back into the blood so that there's less LDL flowing in the blood. Thus, we have less cholesterol. Than because we want less cholesterol because familial hypercholesterolemia has symptoms, signs and symptoms that demonstrate high cholesterol levels, and we want to get that number down, to lower your risk lower your family's risk of heart attack and stroke.